This time on Finnegan's Garage, we continue to lie to ourselves and to the world by pretending that this twin-turbo Eliminator Daytona is being built for my wife.
Did you just admit it?
Allegedly, maybe, I don't know. And we're gonna build a completely custom fuel cell so we can fit 4,000 horsepower worth of fuel inside of it and drive really, really far. Wow. And as a bonus, we have help. Andy's gonna teach us how to TIG weld aluminum better than we ever have before.
Yeah. And you got a new machine to do it.
Oh, it's gonna be a good day.
Mm-hmm.
Ready?
Yeah.
Let's go. My wife loves nothing more than riding shotgun in a really fast jet boat, sipping a cocktail while going 140 miles an hour with all of her friends, which is why we're building her boat. And the first thing you need to make a jet boat go, obviously behind the motor, is a gas tank. So we're building a 30-gallon aluminum fuel cell here on Finnegan's Garage. And gotta be honest, my aluminum welding, not amazing. Thankfully though, folks at Miller Welders sent us Andy. And he doesn't get to leave here until we finish this project. They said that to me. They might not have said that to you, but they said that to me. They said, Andy is all yours. Figure out how to work your new Dynasty 400 DX and lay down some fat dimes all over this thing so that it fits in the boat, holds the fuel, and this goes inside of it.
And doesn't leak.
Yeah, doesn't leak. That's kind of a big deal.
That part.
The not leaking. Wifey doesn't want a leaky jet boat.
Yeah.
Yeah, we can make that happen.
Although she didn't communicate that to me, I feel like that's inferred automatically. You know, you get married, can't build her a leaky jet boat. Pretty sure that's how it goes. So Andy's here because we have a new machine. We need to build a fuel cell. And the old machine was amazing. We had a Dynasty 280DX for like 8 years. It was great. Apparently I don't have it set correctly at all. Which, you know, in the end, it's pretty cool. We made a fuel cell for blasphemy that didn't leak, even though the machine was set wrong. We made, oh, it was wired wrong too, yeah. We've done some things with not the best setup for our equipment. So we have a new welder here today. Andy's gonna set it up for us. He's gonna teach us how to use it. And he's gonna show us some techniques that are gonna make welding a bead from one end of this fuel cell all the way to the other a lot easier.
It'll make it look like a machine did it.
Yeah, that's the goal. And so first things first, this looks like it's done. We need to take it out of the boat and show you how undone it really is. So my friend Brian Rakestraw was kind enough to cut, bend, and tack this together. And as you guys are gonna see, there are 1, 2, 3, 4 seams that are not welded on this at all.
Oh, this blanket in the back of the El Camino, we'll put that in the back of the El Camino.
That's a great idea. Let's use her car to hold her parts for her boat.
It's only fair.
Ah, she would do this. This is what she would do. All right, so our bulkhead is off. Again, we didn't build this fuel tank because we're not that skilled, nor will our sheet metal brake accommodate something this long. My friend Ryan Rakestraw bent this whole thing and tacked it together. And after doing so, we realized we wanted to run an in-tank fuel pump, not an external pump. And so enter the Aeromotive brushless 90-degree outlet, just gonzo fuel pump. This thing, and they make other ones that are way more powerful than this, but this particular one will flow 1,000 pounds per hour of fuel.
That's
right. Yeah, that is a lot of fuel. That's enough fuel if you're EFI and you're supercharged. That's enough for 1,400 wheel horsepower. If you're carbureted, you can do 1,700 wheel horsepower in a supercharged application or turbo application with this pump. And the thing I like about it is the 90-degree outlet, because that's going to shorten our overall height. And we don't have a lot of room above the tank here. And we really want the pump to sit level. So what we're about to do is create an enclosure that drops down from here, comes straight across to here, and gets welded here. And then our pickup is going to end up down here at an angle on the bottom of the tank. So we're going to take a piece of aluminum tubing and put a nice S-bend in it there. So my question to you, Andy, is I really want the flange that this bolts to be thicker. I want to drill and tap it. Aeromotive provides a clamp that will go inside the tank that you can bolt to, but I don't think I'm going to use it. So I was thinking 3/16 aluminum plate across here to bolt this to, but then we're going to be welding it to, this is like, I think 090.
Yeah, looks like it.
Yeah, new welder, I'm really unskilled, new machine, that sort of thing. Do you have any tips for, when we go to cut this out and we go to weld this together? I'm going to rely heavily on you to set the machine up. I got to be honest.
Yeah, no doubt.
That way, if it's wrong, it's your fault. So the next thing here is
I hear that at home too.
we're going to get a plate. We're going to put a hole in it. We're going to put for the pump to go through. Then we're going to put a bunch of other mounting holes in it. And then we're going to slide it in here and make some marks and cut this out further, because ultimately this is going to be flat and it's going to go up. And it's just going to have a recess right here for our fuel pump. And then we're going to weld this baffle into the tank. And once we're happy with all that, then the bulkhead can go back on, and then we can make those really long runs of TIG welds, which, again, I want to do it, but I want Andy to show me how to do it.
I got a suggestion maybe for your baffle.
Yeah, lay it on me.
So you see how deep it is in here. And a lot of times when I'll make a bigger tank like this, even though these guys did an outstanding job with this, I make my baffles like a little taller, and I'll actually run some ventils on the top to equalize the air as you get that acceleration and you're moving. Well, in this tank, you're probably moving a couple 100 pounds of fuel, right?
It should hold about 25.
Okay. Yep. So
because we're not filling it all the way to the top, since the pump is going to be here.
Yep.
We're never going to fill this thing all the way up, because the gasket, and Aeromotive will tell you this, the gasket will not be happy with fuel up against it full time. So we won't fill it all the way up.
But just maybe even for ease of putting the baffle in, a lot of times when I make my baffles, I'll actually make them with a couple tabs on here, and I'll bend those at a 90, because it's easier to weld a fillet weld here and here and here and here than try to get the torch inside this, tighter area. Without maybe a custom torch, and I've got a custom torch. I have a
flexible head.
It's got a flex head, but it also has interchangeable heads. So I could actually put a pencil head on it, so I can go straight into it, and then the torch handle isn't at some real obtuse angle, and you're trying to bend the lines.
So I have struggled with that. So we should build another one of these bulkheads.
I don't even know if we have to build another one,
or add tabs to it.
That's, I think, what we could do is just take the same material, we'll bend some 90-degree tabs. We'll weld them flush to this, flush to that. We only need to do it on two sides, because again, this isn't actually a piece of material that's going to add structure to the tank. These guys did an outstanding job, and you got multiple bends here, so it's not actually being used to keep the tank structurally sound.
Got it.
I think that's what we'll do.
All right. Next step, we need to put a 3.5-inch diameter hole in that 1/4-inch plate. And this is not the drill press you should be using. In fact, never forget, the bulk of what I'm showing here is not done by a professional. You should take all of it with a grain of salt, avoid much of what I show you, and do things in a better, faster, more efficient, safer manner. However, this is what I have, so I'm going to use it. And maybe it works out, maybe it doesn't. Dave, can I have the lube?
Sure.
It's an odd question, but necessary. It's highly likely that this will not work, because this is probably the most gutless drill press that they had available on Amazon that day. But it was inexpensive, and I liked it. It's a nice shade of orange. Oh wait, let me tighten the table down. Remember what I said about not doing everything I'm doing? It's a horrific noise, but it is working. I'm just gonna put ear protection on. You guys at home probably should do the same. Oh yeah, that's better. That's better. Yep. Underpowered. I'm gonna keep going though. Now we need a 3 3/8 diameter hole in here. I don't have a 3 3/8 diameter hole saw, but I do have a really sloppy mandrel here and drill press and a 3 1/4-inch hole saw. So we're gonna end up where we need to be. It just won't be very pretty. And we might be here for a while. Yeah, we're about 10% of the way through. So you guys go get a sandwich, and I'll see you when we're done. Oh yeah, look at that. We're probably 30% of the way through here. I may go get a sandwich. I may get the 1/2-inch drill and try not to break my wrists. That's what I'm gonna do. I've given up on this. Oh, we need the fume extractor. Let me just get a let's dialed in. You know what they say? Happy wife, happy life. Oh, we're getting close. I got wood. Aha! And we got a free washer. Is that the right size for the?
It's gonna be. It doesn't have to be a certain size.
I think that might be the right size for the sending unit, dude. Big day here at the shop. Obviously, this is the biggest fuel cell we've ever created here at Finnegan's Garage by a lot.
Yeah.
We're also getting a bigger welder here. This is a Dynasty 400DX inverter machine. It's a monster. We're going to be replacing the smaller 280DX that we've had in here for about 8 years. Amazing welder. We've built everything on Finnegan's Garage with this machine, and I've really enjoyed it, which is why I'm going to give it to you right now.
What?
Yeah.
Dang.
I think you should take this home because I know you want to learn to TIG weld.
Yeah?
Yeah.
For real?
So take that home, learn to TIG weld, and we'll be using this here from now on.
No way.
Yeah, man.
Dude. See you later.
Yeah.
See ya.
Yeah. Get better and come back to work. Okay. So for the purposes of what we're doing here today, we are going to weld our fuel cell using this. However, I don't know if you realize this. The 220 AC/DC is a TIG welder also, and we use it all the time. We use it all over the shop to tack things together. And then if we don't finish weld them with this machine, we'll finish weld them with this one. The thing I'm curious about here is today I want to learn about pulse welding.
Yep.
On the fuel cell with this. Can I do that with this? Because I know you can pulse DC, but can you pulse AC?
Yeah, no, actually, you can do it on DC and not on AC.
Okay.
So the machine is designed really for the person who maybe doesn't have as much welding experience as you have. And so it has that auto set feature, which works in all modes. It has auto set in stick, TIG, MIG, but you can also take it out of auto set and run it fully manually. Now, when you take it out of auto set when in TIG aluminum, you're welding in AC. And when you do that, you get a couple extra parameter settings that you can adjust. One of them is balance, which also affects that oxide cleaning area, and the other is frequency. And frequency focuses the arc tighter or wider, which that machine obviously has as well, but it has a much more expanded range than what this one has. So this one, the frequency goes up to about 150, and the balance is fixed from, I think it's 60 to 80%. So it gives you a much narrower window. It doesn't allow you to screw it up, in other words. Okay. So it's much narrower, but when you're in DC TIG and you take it out of auto set, you get, again, a couple extra parameters that you can adjust, and one of those is pulse. So you can add the pulse for that, but it also only gives you pulses per second that you can adjust. So there are basically 4 parameters to pulse. You have peak amps, you have background amps, you have peak time, which is how long you're at that peak amperage, and then you have your pulses per second. Okay. So with this machine, you can adjust all those variables independently to get that perfect pulse, and it matches what you're actually doing too. So if you want to set it slow to more of a manual pulsing mode, and you just don't have quite enough heat with this machine, because you can only adjust pulses per second, you actually have to turn up the main amperage to get it to go to give you more power. Okay. Right? Which this one, you could just increase the peak time or the peak amperage. Both of those would actually give you more average power.
All right. And for you guys at home that are just learning to weld, I can boil that down for you. Essentially, this one will pulse DC when you're welding steel. Stainless steel, that sort of thing. It will not pulse when you're welding AC, which is what you'd use for aluminum. This will do both. So this is a more expensive, more flexible machine. This is a do-it-all machine. This one will not make welders stick weld. This one will. So this is a great machine for, you guys at home. They're going to do a little bit of everything, but you're not trying to specialize in any one thing.
Yeah, and actually that will stick weld. But
really?
Yeah.
I've never stick welded anything in my life. That's probably why I didn't know that.
It's the Lamborghini of TIG welders, and I'm sure you could take a Lamborghini off road. I don't know many people that do it, but again, it does stick weld. but I don't really know anybody that does it.
All right. So the next step for us here then is to prep the pieces we're going to weld on there. We still have to do a little more cutting on the fuel cell. And then Andy's going to show us how to set this machine up to pulse that. And then I think we should grab some scraps also to show people how to pulse on that as well.
Sure, we could do that. Yep, excellent. And we'll even do a variety of pulse settings. One of them is actually a faster pulse where you can literally lay the filler metal right in the joint and let the machine just pulse it in. So,
ooh, I've never done that either.
Yeah.
It's exciting. All right,
cool.
I'll get it plugged in.
So I guess we'll start out with the little mini-me. We'll do the Multimatic, and we'll do the pulse on DC. So for me, pulse, I like to do with my beginners, I'll set the pulse real slow, and it actually works on their timing, and it helps them get that rhythm going. So that seems to be the biggest thing that people have a hard time with TIG is learning that rhythm, because one hand's holding the torch steady and the other hand's adding and depositing the filler metal, all while you're controlling a foot pedal. So, you know, the foot pedal's your throttle, how much power you're gonna use. So really, again, it's gonna be just about the same way. You're going to be watching the puddle start and establish, and then the machine's going to start going into its pulse. So every time the machine pulses high, you'll add the filler metal. Every time the pulse goes low, you're actually moving the torch. And then that kind of will start your rhythm, and then you can just kind of build up speed, and pretty soon you're end up kind of welding regular, and you can turn the pulser off at that point, you know?
Ah, so for the guys that are learning, learn to pulse first and then turn the pulse off.
Yeah.
That's a good idea, because learning to pulse, I didn't learn to pulse right away. I learned the regular way.
Yeah.
Then when I had to pulse, it was hard to stop my brain from doing this at the same time.
That's what happens with most men. Yeah, most guys, as soon as you can do this, and again, I teach people to do it, you know, statically first. I'll have them take their filler metal and their torch, get comfortable, of course, sit on their chair, which is missing, and, you know, get the right angles, right? So you're going to be 90 degrees to, in this place, it's just a bead on plate, so I'm 90 degrees to the piece this way, with about a 10 to 15 degree push angle. And then typically you're coming in about 90 degrees to the TIG torch with your filler metal. And you can do this and practice this all day long, and you can be like on the money. But as soon as you put on that helmet and step on that foot pedal, everything happens together. Right? And then you got a mess. So, yeah, so for me, I think that's great to do that exercise multiple times, but just keep in mind that when you do it, when you think you got it down, keep doing it.
Yeah.
So,
well, you know what is going to help a lot, and I don't know where my helmet is you swap the lens out to the new one, and the new one is night and day different than the old one.
Yeah, you have to let me know what you think about it. So the new Clearlight 2.0.
Yep.
You know, my first impression is I you know, and I'll have to let you tell me what you think, but for me, I like the fact that, like shoes, everybody's shoes are different sizes.
Okay.
You have half sizes with shoes. Well, I'm the guy that wants that shading like between 10 and 11. Now you can do that. It's like they actually have a 10.5 setting, like, or if you want 9.5, 10.
So you're excited about the adjustability of it.
Yeah, I'm excited about the adjustability.
I'm excited the world's not green now. You know,
that's a
like
bonus.
the Clearlight lens, the original one was great. You know, it was way better at showing me colors than the old stuff. But the new one, when you first, you know, put the helmet on, everything is kind of silver instead of green, and so everything's brighter. It's easier to see. So before you even strike an arc, like I can see everything better.
Sure.
Whereas before, I'm got flashlights all over the place, trying to get as much light in the weld area as I can. I don't think I'm gonna. I don't think I'm gonna have as much of a struggle with seeing now that lens is in my helmet. So I'm fired up about it.
Cool. Well, you have to let me know when you're welding your tank.
Yeah. Oh yeah, for sure.
Okay, so first what I'm gonna do is, I'm gonna take it out of auto set. Right now I've got it at auto set. All you gotta do really is tell the machine what tungsten you're using, which we're using 332, and the material thickness, and it puts me in that amperage window.
Yep.
And I've got some adjustment up and down for that. And so then I'm gonna take it out of auto set, and now it opens up another parameter we can adjust, and that's called the pulser. So now I have manual control over my amperage. So I'm gonna set this up a little bit higher than what you would normally weld on 1/8 inch.
Yeah, because when you pulse, it has to be higher.
Yeah,
you know?
Because you're losing that low cycle of the heat input to the piece. Yeah. So the average heat goes down. So I'm gonna just set it up at 150, just for a starting point. And again, you're going to be able to adjust that with your foot pedal anyway. And I'm going to start my pulser at, let's try it at 0.9 pulses, almost 1 pulse per second.
Okay.
That's the only adjustment I have on the pulse on this machine. Unlike the Dynasty, you have much more adjustability.
Right.
So at this point, we'll make a test pass. Turn on the argon, that would help. 2 things that you will forget sometime in your life: turning the gas on and
Forgetting to ground it.
clamp on.
Yeah. When you don't ground it, that gets your attention.
Yeah.
Sometimes when you get shocked.
Yeah, especially if you're in a little hotter, sweatier environment.
When I first learned to TIG weld, one of the people that taught me started making his own really large gas cups, and they were made out of metal. I think they were titanium.
Really?
And Lord help you if you didn't have the workpiece grounded and you actually touched that cup to the workpiece.
Oh.
Shocked the crap out of me. I actually stopped using the cup because of that, because I frequently get in a hurry and forget to put the ground on.
Ouch.
And yeah, I'm a big fan of the Pyrex and ceramic cups now. A lot more forgiving. Except when you drop them. You know, the metal cup was great. You could beat on that thing pretty good.
Yeah, it's durable. But
getting shocked was unfortunate.
you're probably not going to see this at home because the arc is going to be bright, so you're not going to actually see the puddle developing. But you'll definitely see the pulsing high and low and high and low. So you see how it's pulsing up and down?
Yep.
Every time it pulses high, it's forming a puddle.
Yep.
So I'm going to add when it's pulsing high, and I'm just moving the torch over when it's pulsing low.
Yep. It's very smooth.
Kind of get that look. Actually, this table started moving on me. It started getting closer. Now, what I'm going to do a little bit, I'm just going to turn it up a little faster. So that's 1.1. That's it. So just a little bit more, and you'll see the difference. I'm going to have to like pick up the speed and go a little faster.
Okay.
So this is kind of what I'm talking about is, so you can see it pulsing faster now?
Yep. So we do a lot of stainless steel header builds here.
Yeah.
And would you prefer to pulse that DC as opposed to not pulsing it on thin stuff like that?
Yeah, partially because the stainless starts sinking heat, right? And so it gets hot, and
It moves
using
a lot.
the pulse does reduce the warpage too, right? Because you're reducing that total heat that's going into it.
Okay.
So yeah, I tend to pulse a lot with the with stainless and stainless tubing.
Cool.
Yeah, and it works real good if you. Now this one only goes up to 150 on the pulser. So to give you an idea what that looks like, is
I've never gone over like 1.5.
yeah. So this one, I'm not even going to worry about trying to keep up with that. You're not going to, right? Just because it's going so fast.
Right.
But again,
Will it sound like a MIG weld basically?
no. But it'll be. Now here, listen to it. Right.
Oh, it sounds like you're doing AC.
Yeah. So it helps. It helps pinpoint. It helps pinpoint the arc when you're pulsing really fast. So you can see how narrow the weld bead is, right? So it helps pinpoint the arc when you're going really fast. So it adds precision to it. But it still also, because it's pulsing up and down, it still reduces the heat that's in the piece as well.
Okay, so like...
So, you know, like in the middle of your collector. Like, so if you got a collector, you know, you got a merge collector, and you're in that deep part
where
of the
everything's
collector
really
where it's really thin and tight. And so I'll usually tack inside there first, and I'll tack the back, I'll tack it a couple of places, and I'll start on that inside, and then I'll start coming this way. You know, with that high pulse like that, the arc is narrower. So when you're in that, we'll call it a crevasse, that arc isn't wide enough where it's trying to melt the tubing up higher within the inside of the collector.
Okay. That's cool.
That kind of makes sense.
Yeah, and so on the exterior of those tubes, you're butt welding 2 tubes.
Yes.
The stuff's like 065 stainless usually. What kind of pulsing are you using there?
I'll slow it down then, because there I've got more control, and you're usually going around the tube anyway. So I'll run mine because it's a manual operation. And for stainless and for steel stuff, I'm not actually laying the filler metal on and like washing it into the joint.
Right.
So I'll do that manually. And so I'll run it slow. I'll run it around anywhere from 0.8 to 1.1. Again, where I had it set before was probably the maximum I would go on a tube, especially because you're trying to, you know, articulate yourself and go around that tube. So
I struggle with that, like getting my hand to have the dexterity to rotate over as I'm going forward. I can only do like 5 or 6 tacks, then I have to stop.
Okay.
And then I got to reposition the tube here and then go a little further and then reposition it. It's hard.
And I find the same problem when I'm doing roll cages, things like that in cars. And a lot of times what I'll do, and I have a little different torch setup, so it's the cup isn't this big, but I'll even use 1 or 2 of my fingers as actually the standoff point. So, you know, if my finger was long enough, which this is a longer cup, but on your Dynasty it has the proper cup, but I actually use my finger as kind of a standoff when I'm kind of trying to get in that goofy area. But yeah, let's move on to the Dynasty, because the DC, that's pretty much all you can do on that. Your pulse range is fairly limited, up, like I said, up to 150 max, which is great because it still agitates the weld puddle. So if you're working with 2 dissimilar steels, let's say you're doing a chrome moly to mild steel, adding the pulse at a high pulse rate actually agitates the weld puddle, and it'll give you a better grain structure and a stronger weld bead.
Wow.
So, you know, rather than just a straight constant DC where you're adding filler metal, you know, imagine a bag full of different sized marbles. And then you shake the crap out of the bag, they start to line up. And
I'm so glad we're filming this, because much like school, I won't remember all of it, but at least now, like you guys, I can go back and refer to this later and be like, oh yeah, I'm gonna weld chrome moly to mild steel. What did he say about that? I'll go back and watch the video.
High pulse rates,
High pulse rates, got it.
Cool.
All right, I'll plug this one in.
This is a nice tray option. You can build this at home. It also holds the foot pedal and it's 20 feet of cable.
That's why that got built.
All right, so your first time you want to step on the pedal, just make sure you turn it on so that it comes out of the sleep mode. So just tap it, because otherwise if you sit down and put your hood down and you're tapping the pedal and then nothing's happening, you literally got to step on it one time just to get it to
I never knew that.
Reawaken.
Okay.
So that's another thing that I see a lot of people do is they'll grab like 1/16 material and it gets so hot so fast.
So practice on the thicker stuff because it doesn't get hot as fast. And then before we go do the actual fuel cell, we'll get actual fuel cell material so that we can have the settings on the machine correct.
Bingo, right.
Okay,
Yeah,
all right, that makes sense.
For a pure beginner just learning to TIG weld and they're just gonna do a bead on plate, I'll have them do 1 bead. They'll analyze what they've done, and then I'll tell them, set that away and let it cool. Don't keep welding on that same piece, because every time you weld on it, it's going to do something different. You're not calibrating your brain and your eyes and your hands, no way, because the puddle's doing something different every time.
Right.
So set it aside, let it cool, come back to it later.
So that's why you have all these little coupons.
Right, exactly, yeah. So
Fresh one every
I've already taken a wire brush and brushed it and kind of cleaned it. So, you know, clean that oxide all off. So, you know, this is best practice. Is it practical in every situation? No, but at the same time, you know, to literally clean the oxide layer off, and you'll tell when you start getting that oxide layer off because it grabs the brush more. It starts to get, you know, because you're getting out of the real hard oxide layer down to the softer aluminum.
What's your opinion on only going one direction when you do that?
It doesn't matter, because when I'm doing this, you're still gonna wipe it off with acetone. But my biggest problem I have with people is they're contaminating these by using them on other materials.
Right.
So they'll brush steel, they'll brush something else with it, and then they'll brush it into the aluminum.
Got it.
So I label mine, you know, but I still got some people that don't know how to read and they still grab and contaminate my brushes. So
that's the aluminum one. You're good there.
Yeah, awesome. So this is kind of a, you know.
Do you ever acetone a filler rod or?
Yeah, absolutely. Yep, because it's forming an oxide layer too, and I love that your setup. You've got them in tubes so they don't get this contaminated.
Even in the tubes, and like they come out dirty when you wipe them off.
So even this piece here, you can see how clean it is. I mean, you think, man, that's awesome. It's super clean. I'm just gonna go weld with it. But I mean, you can guarantee that I mean, I didn't brush this at all.
Yeah.
I mean, it still has.
Yeah, you can see where
contamination.
You made it shiny right there where you wiped it.
But that piece looked perfectly good even before I didn't even brush it. So at least the bare minimum you should do is, acetone it. Get some of the the residual contamination off of it. And if you're working with a sheet that has that plastic coating on it, that plastic coating doesn't keep it from being contaminated. It actually has an adhesive on it. So when you peel it off, it looks beautiful. Yeah. But if you go to start welding it, a lot of times it'll put some black spots on it. You gotta clean that.
Okay.
Yeah. Pretty good.
Yeah, I saw you working on that stuff before. So no, that's a good habit to get into. Especially that stuff with that protective film on it. Okay. So this is an outside corner. Probably not gonna take as much power as what I'm actually welding at right now, but I'm gonna turn my pulses per second up to, let's just do it at 1.3. And I'm gonna do that little kind of trick where you just kind of lay the filler metal in the weld joint and just let the machine do the work.
And what frequency are we at?
Right now I'm at 1.3 on the pulse frequency, and my weld frequency is 120.
Okay, all right.
Yeah.
Wow, this is cool. So I've never welded that high of weld frequency.
Okay.
And it looks so much more controlled, because like I learned to weld everything at 60 hertz.
Yeah.
And it's a pain in the butt.
Sure.
And I never knew that I could turn that up.
Just even doubling it adds so much more focus to the arc that you're putting, like when you're welding steel, it's in DC all the time, so it's always very pinpointed. Welding steel is easier in most cases than aluminum, because in aluminum, especially in 60 hertz, the arc is wider, so a lot of times it doesn't even go where you want it to go. So if you're welding in an included area like this, and you're trying to weld in there, a lot of times the arc is slapping the sides of the base metal instead of going into the root of the joint.
Yeah.
Right?
I've completely had that experience.
Oh yeah.
This is gonna be awesome.
So this, a little bit different, and we might have to make an adjustment, but this is kind of what I'm looking for. Okay, so I'm gonna make an adjustment. I'm gonna melt that off, okay? So what happened there was my arc, you can see the pulse time, the peak time, isn't enough to keep melting the rod into the joint. It's coming off too fast. So now I'm gonna make that adjustment on my peak time. I'm gonna turn that up to 50, and let's see if we get that dialed in a little bit closer. And I usually get the puddle started first. So we can still fine tune that a little better, but you kind of see what I'm going for.
Yeah, so I'm
not even manipulating the filler metal.
You're holding it there and you're dragging it backwards, right?
Yeah, I'm dragging, no, I'm not even moving it.
You're not even moving it, okay.
My goal is to get the timing of the pulse high enough and fast enough that it just pulls one droplet off the filler metal and rolls it into the joint. So I'm not moving this at all. I'm literally laying this almost in the weld joint like that, letting it pull one droplet off the filler metal as I'm moving along. I didn't even move my hand one bit.
Wow, see, I didn't know. It looked like you were.
Kind of did, yeah. So sometimes that's the cool part about it. If it pulls too much off and then that gap gets a little too large here, which I wish they could see this, but if that gap, when it pulls that off, gets a little too large, you can, add it in, obviously.
Could you just do that?
Yeah, so I'm gonna do.
So like on a long tank run like that thing,
and
just lay that thing in there?
Exactly kind of what we do. I'm gonna go up to 1.4, change these a little bit.
Yeah, the reason I thought you were moving it is it was coming in at an angle.
Yeah,
it wasn't flat. And
it kind of looked that way. So really, what I was doing was I was coming in at an angle, but I was putting downward pressure on the filler metal.
Oh, okay.
So let's try it this way. You see it now? Okay, so there it pulled it off, so I'm gonna just come back at it. Does that make sense?
Yeah.
And we still might have to work a little bit on our pulses per second, on our peak time. So my peak time right now is 50. That might be just a little bit too much. So I'm gonna come back to 45. Now I left the rod in there just to see, show you that I wasn't moving it at all.
Dude,
So that's
that looks
pretty
good right at the end, yeah.
So we're pretty close there. So that's kind of what we're looking for.
That's
you
cool.
know, on that kind of a long run. That's pretty much how I do my heat exchangers and stuff too, the long runs on radiators.
Wow.
Yeah, I'll lay that, when I'm doing mine, it's actually a lap joint, so it's a little bit different. So your settings are gonna be little, right, obviously. So you got the tank on the end, so it's actually a joint that looks like that.
Okay.
You know, but the concept is still the same. So that's what we will do when we kind of imitate what you're doing on your tank, is we'll make the same joint. So I know some of your tanks are outside corner welds like this, and then the other ones are outside corners also, but they're at a less severe angle.
Right.
You know, they're probably on like a, maybe what, 15-degree angle, if that.
Right.
So.
Oh, that's cool.
And I liked it because, you know, you have the option of just let it eat, but then you also have the flexibility of the foot control. So you can always, like where I had a spot there where it didn't deposit a little filler, I just let off, backed up a little bit, filled it up, and just kept on going.
Are the rest of the time were you just wide open?
Yeah.
Oh, that's cool.
All right, you wanna try it?
I would love to try that.
So what I'll do first is, obviously I'll just get the puddle started first, because if you don't do that, two things could happen. First, it'll pull a droplet off the thinner filler metal and deposit it, but it'll be a cold initial joint there. So, especially with your fuel tank, we don't want that. So in this case, you're coming in at a kind of a severe angle. I mean, you're coming in at a normal angle I would be for like manual stuff.
Right.
But I would actually come in a little bit even lower.
Oh, because you want me to just lay it in there this time?
Yeah. So do you want to not lay it in there first? Do you want to just try a slow pulse? You know, where you're adding and moving, adding and moving?
Sure, why not?
Okay, so let's do that. That'd be more of like a manual mode. There you go. Add. There you go. There you go. Nice, that's a good rhythm right there. You just kind of have to anticipate it a little bit. When it pulses high, get ready to hit it in. That's all right, keep going. Pull it up.
Whoops.
Hey, but look at that. That's smoking good for the first inch and a half.
Hey, that wasn't so bad.
No. And ease up. You're getting real hot at the end. Yeah, so that's still...
It got away from me about an inch ago, and I was backing off slower, but I was backing off way too slow. Yeah. So by the time I got here, it was
just
too
nowhere
late.
for the heat to go. If that piece was longer, you wouldn't, seen that develop that fast. Plus, we already welded with it, and again, it started saturating heat anyway before we restarted. So
it was impressive that I bonked it and it still welded fine after the fact.
Oh yeah,
like, even though the tungsten's probably really contaminated.
So are you gonna try and do this manually or just lay it in the joint?
I forgot all about laying it in the joint.
Yeah, so we're kind of at that setting right now.
Okay. Now, do you lay it in the joint before you ever start? Or?
No, I get the puddle started first, because if you don't, possibility of having, kind of an incomplete fusion on that first puddle pass is important. So always still get the puddle established first.
Okay.
Ease up, there you go. Good. So you saw what happened there. You still picked up well. You still stayed ahead of the heat soak from the material.
That was fun.
Yeah.
Oh my God, that's so much easier than dipping for 7 feet of weld on one seam.
Oh yeah, no doubt. So turning the pulsar off. So now I'm gonna turn you down, because you don't need 120 amps.
All right. So this is no pulse, 120 amps,
Yep.
1/8 inch. Okay.
So you're gonna see that the arc is still pretty focused, and it's just gonna even be all around easier to weld with this type of arc.
Yeah, now it's really contaminated.
No, not bad.
That is way easier than welding it at 60 hertz.
Yeah.
I wish I had learned about that years ago.
I noticed you dipped it in there. So
Yeah.
this machine responds so fast to arc changes. It makes it makes the inverter engine in this thing, it's so fast and responsive. I mean, literally it can respond to arc changes 60,000 times a second.
Wow.
Like a regular machine, it can respond 60 to 120 times a second, like a Syncrowave or some of the older transformer style machines.
Right.
So what this machine does now, if it sees you touch it, which is a dead short, on an old machine, if you're welding at 150 amps, you have a 150 amp dead short, and boom, you blow the puddle apart.
Yeah, it's
So
messy.
what this machine does is when
It didn't do that.
Yep, it doesn't do that. So what it does is it actually phases the output. It can measure this distance once you start welding. That's called arc length. So it can measure that arc length, and as soon as it gets so close and you touch it, it already has done phased the power off, so you don't get that big explosion. Right? So the only thing it can't measure, because there's nothing tied to it, is the filler metal.
Right.
So if you accidentally stuff this, like you got to work at it. But if you take the filler metal and stuff it on the tungsten, you will, permanently contaminate that piece, and you got to cut it off and grind it. Right. So what I'm gonna do is I'm just gonna hit this over, and about 3 times I'm gonna take here and I'm gonna drive the tungsten into the piece and keep on going.
And keep going. Okay.
All right, ready?
Yep.
I'm still on the foot pedal.
Wow.
So
Oh my
you'll see I'll
goodness.
get an arc blow here, and
Yeah.
I'll have a little bit of contamination at that spot.
Yeah.
But that literally wipes right off.
Yeah, that's incredible.
I mean-
Because in the past, when I would do that, it would be so contaminated that it would carry it with it after
Yes.
that.
Yep.
And pretty much you had to stop welding because it would get so hot. It would just melt everything. You had to stop, and you had to brush it, and you had to acetone it, and you had
Yes.
to chop the tungsten off. And
Yeah. Now look at the tungsten. It still looks the same
Wow.
as it
Yeah,
was
like-
when I started.
visually there was a color change, but
Yes.
it didn't look like the arc wandered that much afterwards.
No,
Like, that was
what it
impressive.
does for just a split second, you'll hear that arc crackle, crackle, crackle. The machine's literally cleaning the tungsten off.
Wow.
The AC is so sharp as it transitions from positive to negative, it'll actually clean up the tungsten, and it'll smooth out as you roll along.
Oh my goodness.
Again, like with your rhythms too, once you start that dab and move rhythm, you can still pick up the speed. I tell all my people it's about puddle control. So as I'm going and I'm dabbing and moving, once you get that motion, you can pick up the speed. You've got to add a little bit more throttle. But look at my puddle. I'm just keeping the puddle right underneath the tungsten.
Oh yeah. Wow.
So it's just a matter of managing
That
the
was
puddle
fast.
control. Yeah. So really, you can still do it fast even without the pulsar. The pulsar kind of makes it more of a sleeper moment, so you can kind of enjoy your morning coffee while you're welding, I guess. So we upgraded Mike's helmet to the new Clearlight 2.0.
It's good.
So in my eyes, it's like going from HD, which is great. The original Clearlight was an awesome step up, but now Clearlight 2.0, it's like jumping up to 4K. So the clarity is there, but also that green tint that you normally see when the helmet is in its ambient state, its clear state, that's gone now. So you have a much more clearly defined clear state and more adjustability on the shading too. So we have half shades, so you can go up to 10.5 or 11.5. So you know, much better adjustability. So I'm going to show you both versions, the old one and the new one, while Mike's putting down a weld bead.
Okay.
All right, hold on 1 second. Let me make sure I got the... I'll give you a go. My lens is down. They're both set the same. Original, go.
Okay, here we go.
So what do you think about that?
The new lens is great. I see way better, which means I'm gonna bonk the tungsten fewer times now.
Bonk the tungsten, which is a technical term.
Yeah, bonking the tungsten is when you run it right into the workpiece and contaminate everything.
Yeah, not to be confused with blanking the tungsten, because it's a little warm.
Like right now, when it's down, I can see so much better because there isn't the green hue. Like I don't feel like I'm in an action movie, you know?
Movie.
It's awesome.
Now you can get to action. I
don't feel like I have my night vision goggles on. Cool. Let's install a fuel pump. Right about here. Yeah, I think we're pretty good.
Okay.
I like it. So now we just need to box this and this.
Yep.
And then the end plate goes on after we weld that in there and it's done. Looks great. I bet it fits really, really good.
Yeah, we hope so. We actually measured it this time.
Yeah. Oh yeah, that works good. Here's the deal. I'm nearly out of argon because I'm a poor planner and didn't think to fill the bottle up. Right now we're going to tack this in place, drop the fuel pump in so you can kind of see how it should be. And then tomorrow I'll go to the welding store and I'll buy more argon and a lot of filler rod and finish welding this entire thing.
Excellent.
The biggest fuel cell we've ever made here in Finnegan's garage. Lots and lots of weld, lots of filler rod, lots of potential for leaks, and lots of starting and stopping for me as I got more comfortable doing this. So
I have a question
in the future, I will not start and stop as often as I did because those are potentials for leaks. What's your question?
Do they have like a smoke machine or something? Like, can we fill this thing with like smoke and then put air to it? And like, would the smoke come out pinholes or no?
Yeah, we just don't have that.
Oh, I just didn't know.
Yeah, they use that for diagnosing leaks in engines and things and stuff, yeah. But we don't have that. So we'll risk exploding the tank with possibly too much compressed air. Perfect. And a bottle of soapy water.
All right, sounds great.
Okay. Do you want to insert the, whatchamacallit?
That's weird.
Sweet.
Yeah, I'm gonna go get me a little chair. I'll just sit here and just I'll handle this the whole time. This box got welded to this box on the back side. And there must have been a pinhole there because it shouldn't have leaked through on this side if it was welded on the back side. So we'll just run it over and it should be all right, man. Wow. Yay, us. All right, fix one pinhole and just fix a pinhole and then make a sub harness for this. A couple of fuel lines that can go out and this thing can go in. Oh, that looks good. That's like 25 gallons of goodness right there. At least. That thing's huge. It's 6 foot long. It's almost as tall as me. As long as it doesn't leak. It's as good as me. But you leak. Nah, I really don't. I mean,
purpose sometimes.
Mm-hmm.